Hey everyone, it's Justin again. Were you surprised to see functions in the lesson title? Maybe you're even thinking, Justin, we spent like a whole bunch of units learning about functions already. And you'd be right, but that doesn't mean we're done with functions. We spent a lot of time talking about linear functions, like this one, but there are so many different types or families of functions, like this one, or this one, or this one. All of these functions are great, but for this unit, we're going to focus on functions like this one, an exponential function. Let's get into it. Using context clues, what do you predict might be involved with exponential functions? Maybe you noticed the word exponent hiding in here? If so, you'd be right. Exponential functions are functions where the independent variable is an exponent. For example, y equals 2 to the x, or y equals 10 times 8 to the x. It's important to note that not every function with an exponent is an exponential function. Something like y equals x squared, even though it has an exponent, is not an exponential function. If you look at our definition, can you tell why this is not an exponential function? Yeah, it has an exponent, but it's not the independent variable. The independent variable here is x, which is the base of this exponent term. Up until this unit, the only type of function we've learned about in depth have been linear functions. We learned that linear functions have a few different forms with some special attributes, and that their graphs will always be a perfectly straight line. Exponential functions are their own family of functions though, so they'll have all different attributes. It'll take some time for us to learn everything about this new type of function, but what better way to start than by comparing it to something we're comfortable with, a linear function. Let's compare our old linear friend y equals 5x with something exponential. Say y equals 5 to the power of x. Let's create an xy table for each of these using -2, -1, 0, 1, and 2 for the x values. Pause the video here and try filling in these tables on your own. To evaluate, I'm just going to substitute each of these values for x into each equation and see what I get for y. In our linear equation, when x is -2, y is 5 times -2, or -10. When we repeat this for the rest of the table, we wind up with something like this. In our exponential equation, when x is -2, y is 5 to the power of -2. I know that a negative exponent means this has to move to the bottom of this invisible fraction, making this 1 over 5 squared. 5 squared is 25, so the y value is 1 over 25. When we evaluate the rest of these x values, we end up with a table like this. If you need to make any corrections in your tables, now is the time to do so. Now that we have both tables filled in, we can see some cool differences between them. Check this out. In the linear function, every time the x value increases by 1, the y value increases by 5. But in the exponential function, when the x value increases by 1, the y value, well, sheesh, here it increases by 4/25, and then it increases by 4/5. And then it increases by 4, and then it increases by 20. That's a mess. But what about, there's no consistent increase, but maybe we're just thinking about this wrong. Instead of an increase or decrease, there is a common ratio or factor between these points. From each row to the next, the y value gets multiplied by 5. And you know what? That makes sense. An exponent represents repeated multiplication, so every time we increase the exponent by 1, we're telling the function to multiply by 5 one additional time. Now, if we plot these points on a graph, we see another interesting difference between linear and exponential functions. While the linear function makes a straight line, as we could have guessed, the exponential function makes this really sharp curve because of how the y values get really big really fast once the exponent is positive. And actually, this sharp curve is something that we'll see in all exponential functions. Of course, we have a whole unit ahead of us to learn more about exponential functions, but I think we're off to a great start knowing that they are functions where the independent variable is an exponent, that the points will have a common ratio or factor instead of a common increase or decrease, and that the graph will create a curve. Once you finish up with this video and your guided notes, you'll need to put that new knowledge to use in the online practice. I can't wait to jump in and learn more about exponential functions with you. I think that they'll be exponentially more fun than linear functions. But maybe that's just because they all have cool powers. Anyway, good luck with the practice, and I'll see you next time.